15 says, if f of x equals 2 to the power of x squared minus x minus 1, find the equation of the tangent line to f at x equals negative 1. So anytime you see these words, equation of a tangent line, a line is a straight line. Tangent is the line that touches the graph at one point, specifically at x equals negative 1. And to find the equation, we need the equation of a line. So remember, the one equation we're always going to use in calculus is y minus y1 equals m times x minus x1. That's called the point slope equation. We already have our x1, right? This is the point we're concerned about. So we know that x equals negative 1. I don't know what y is yet, but I can figure out y by just plugging in negative 1 into my function. So I know what y is by plugging in negative 1 here. So my point is negative 1 comma, and then it would be 2 to the power of negative 1 squared minus negative 1 plus 1, or sorry, minus 1. So that's 2 to the power of 1 plus 1 minus 1, or in other words, 2 to the power of 1, which is 2. So my point is at negative 1 comma 2. So I know that my y1 is equal to 2. So when I rewrite this, I get y minus y1, which is 2, equals m, I don't know what m is yet, times x minus x1, which is negative 1. So that's x plus 1. All right, so far so good. So we know our y1, we know our x1. x1 was given to us, it was negative 1, and y1 we just figured out by plugging negative 1 into the original function. The only thing we have left to figure out is m, which is the slope. So we're looking for the slope of the tangent line, which is the derivative. So we have to find the derivative of this function. So let me go back and erase some of this. So the derivative of this function, you should notice that it has an inside and an outside. The inside is what's up here in the exponent. So my inside is equal to x squared minus x minus 1. My outside is equal to 2 to the power of the inside. So when I find the derivative of that, I get f prime of x equals. Now this is not a derivative we use very often, so make sure you look it up in your notes. But 2 to the power of x, and it's also written over in the classroom on the side of the classroom, so you guys can see it up there on the wall when you guys are working on things. But 2 to the power of x, or actually in your notes it'll look like a to the power of x, so some base that's not e, some base different than e, to the power of x or to some variable. The derivative is the function itself, so 2 to the power of I, I'll rewrite I up there in just a minute, times the natural log of the base. So whatever the base is, it's times the natural log of the base. Again, if you're unaware of where this is coming from, go back and look at your notes of when we did derivatives of natural log, the derivative of e, and this was the third one we learned that day. So if I rewrite the inside up here, I get x squared minus x minus 1. So that's the derivative of the outside. That's O prime. Times the derivative of the inside. So the derivative of x squared minus x minus 1 is 2x minus 1. And that's the derivative of the inside. So we have the derivative of the outside, we have the derivative of the inside. The only thing left to do is plug in our points. So I want to evaluate this derivative at negative 1. I want to figure out what the slope of the tangent line is at negative 1. So I'm just going to plug in negative 1 everywhere I see an x in this entire thing. So let me erase some stuff so I have a little bit more room. So that's 2 times, I already evaluated this for negative 1 actually. I already figured out, back up here when we figured out what y1 was, we figured out that this is 2 to the first power. So if you plug in negative 1, you should get that. Times ln of 2 times, if I plug in negative 1 here, I get negative 2 minus 1, that's negative 3. So my derivative is equal to, this is 2 to the first power, that's just 2. So it's 2 times negative 3, that's negative 6, ln of 2. So that is my slope. That's my slope at the point x equals negative 1. So I'm going to plug that in here for m. So I'm going to plug that in here. I get negative 6 ln of 2. So that's my equation. If I look up here, none of these look like that yet because they all have y by themselves. So if I just isolate y and I get y by itself, I can move 2 over to this side. So if I do that, I get y equals 2 minus 6 ln of 2 times x plus 1. And that looks like answer choice D. So my answer is D. So that is the equation of the tangent line.